Okay, so hi, this is Math 145 and section 2.2. So we are going to see quite a lot of stuff: histograms, stem and leaf plots, dot plots, time series graphs. We are going to explore the shapes or the distributions of these graphs as well. We got some stuff here to define and to just get us started. And then we are going to do some examples in these notes, but an awful lot of the examples for this section actually comes through a worksheet called Data Displays, which you will see on the 4th page of those notes. So let's get started. So as the title suggests, we are doing quantitative data here as opposed to qualitative data, which we saw in section 2.1. And the first step in summarizing quantitative data is to figure out if you've got discrete or continuous data. So you'll remember that discrete data were things like that could be counted, like the number of cell phones in a household or the number of children that a couple has. And continuous data would be things that could not be counted, so like the length of movies. So we'll just read this over quickly. If the data are discrete and there are relatively few different values of the variable, the categories of data, which are called classes, by the way, will be the observations themselves. And if the data are discrete, but there are many different values of the variables, or if the data happen to be continuous, then the classes will be created using intervals of numbers. Now, again, we'll see both of those kind of showing up in our examples, so we don't really need to beleaguer the point here. A histogram, it tells us, is constructed by drawing rectangles for each class of data. The height of each rectangle is the frequency or relative frequency, possibly, of the class. The width of each rectangle is going to be the same, and that's kind of like a bar graph, but you'll remember that a bar graph back from 2.1 was drawn so that the bars didn't touch each other. Here on a histogram, the rectangles will touch each other. So we'll see that. We're going to see stem and leaf plots, which is a fun little title for a goofy looking plot that if you don't quite understand what this is saying, I don't think this definition does you much good. But we will get to it, no worries. Again, it's really on the worksheet. I'm not even going to bother reading over that definition because it's a little on the goofy side if you don't already know what you're looking at. The definition of a dot plot. It's drawn by placing each observation horizontally in increasing order and placing a dot above the observation. It is similar looking to a bar graph, so we will see those in the notes as well. Time series data and time series graphs are defined down here. The data itself is time series data if it's measured at different points in time. And a time series graph is simply a graph of some time series data. And I do use the term line graph on that worksheet, so don't get confused with that. Let's move on. So here's our example of drawing a histogram for discrete data. And so we're asking 50 households, or we have asked 50 households, how many cars they had. We're going to draw a frequency histogram for the number of cars per household. And you'll notice here's our data. And just take a second to understand what is going on here. For instance, let's pull out this row here. What this means is that 7 households responded that they had 3 cars. And that was 0.14 or 14% of the total. Notice each relative frequency is just gotten by dividing the frequency by the total. And in this case, the total looks to have been 50. Okay, so number 1 says draw that histogram, and so we're going to do it. Pause me down, read over those instructions, and then start me back up. Okay, so I have my vertical axis down here with the number of cars, and you'll notice that I put 0 cars a little bit right of the vertical axis because otherwise my bar that I drew would be obscured by the vertical axis, and that would be a real pain in the butt. So that's why that's done. And then frequency, of course, along the other axis. And just like I did with the bar graph, I kind of went up here and I was thinking about the various values of frequency that I have, and I noticed they vary from 1 to 22. And so I thought, if I mark my vertical axis by 5s, I can pretty easily and quickly get up to 25, and that will be plenty to get that maximum of 22 up there. So that's what I do. And now I'm just going to draw bars. Now, these bars have to touch each other. So I want the bar for 0 cars to touch the bar for 1 car. But at the same time, I want them all to be the same width. So I need for my bar for, say, 0 cars to go up to a height of 4, but so that its rightmost edge of that bar is right there halfway between 0 and 1, because then the bar for 1 car, which goes up to 13, let's say it's that, starts right where the bar for 0 left off. Okay? And it's always a good idea to label the tops of those histograms with the frequencies, just to give it a little bit better readability. My bar for 2 cars goes up to 22. And again, they butt right up against each other. You see that? They touch. And just to keep on going, and I'm going to keep drawing those suckers in so that I end up with a histogram. Of course, estimating as best I can the tops there, okay? And that's our histogram. Just like a bar graph, a relative histogram will look the same, except the numbers on the vertical axis will be the relative frequencies. I won't bother showing that, but I think you can picture it. I also want to point out that one of the qualities of a histogram is that the bars are centered on those values. So you'll notice that bar here for 2 cars is actually centered around where I put the tick mark for 2. So that is actually kind of important. Okay, now we're going to turn our attention a little bit to continuous data. But before we read those definitions, let's just, to make better sense of it, think about my example down here. What I have here is number of persons aged 25 to 64 who are currently work disabled. And so think about this data table and what it tells me. I've got ages split up between 25 to 34, and then I have 35 to 44, next group 45 to 54, next group 55 to 64, right? And then of course I have the number in thousands of each of those groups. So I took all the data for people who are currently work disabled from all the ages 25 to 64 and split them up into these 4 groups or classes. And so when we read these definitions up here, hopefully, you can look back down at that table and kind of understand them a little bit better. So now let's go back up to the definitions, and it says, the lower class limit of a class is the smallest value within the class, while the upper class limit of a class is the largest value within the class. So if you look at, say, this class, 25 to 34, we have the lower class limit and the upper class limit. Sound good? Okay. It says, notice the classes do not overlap, but encompass all possible values. You notice how the first class stops with people that are 34, and then the second class starts with people who are 35. So they don't overlap. Now the class width is oftentimes misconstrued. So let's look at that. It says the class width is the difference between consecutive lower class limits. The way sometimes this is misdone is they look at the class, says, let's look at this one, 25 to 34, and they subtract those and they get 9, and they say that's the class width. But notice that is not what they tell me to do. What they tell me to do is find the difference or subtract between consecutive lower class limits. So in fact, I would need to do, like, say 35 minus 25 and get 10 for my class width. So be careful with that. Now, if you actually need to determine your classes, like if you have raw data, just a whole bunch of numbers, and you need to organize that with a histogram, you might actually have to determine the classes for your data. And there's some information down here. Now, technically, in MyMathLab and the examples that we do, all those classes will be given to you. So we will read this over a little bit, but not to worry too much about it. But I do, however, want to talk about this because this is a concept that will come up again and again in various forms. And that is this: interpreting what the heck these numbers actually mean. It tells me this is the number in thousands. So for instance, this 2,132 is not 2,132 people, it's 2,132 thousands of people. Well, what does that mean? Pause me down. See if you can write the equivalent of 2,132 thousands, and then start me back up and see if you agree with me. So what I did was I just added a thousands. I just put on 3 more zeros on there, which is really 2,132,000 people, isn't it? So keep that in mind. Again, it comes up from time to time when they give you data like that, and it's good to remember. Now, if you need to ever determine the classes of your data, here are basically some guidelines. First, you determine how many classes you want, remembering that each class will be a bar on your histogram. So you want between 5 and 20. And to be honest, the amount of classes is really an opinion. And so you don't have to worry too much about getting the correct number, because there really is no correct number. Number 2, it says determine the class width. So once you know how many classes you want, you take the largest value, the smallest value, subtract them, and then divide by the number of classes you want, round up, and you'll end up with the class width, which again, back up here, that was that 10 that we used in that table. Number 3 says choose the lower class limit of the first class, choose the smallest observation or something slightly lower than it, maybe a convenient observation. Let me kind of refer back up to that table. Perhaps in that survey that was taken up there, maybe the youngest person was really 27, but it made sense to make the class 25 to 34 just because it would be a nice round number to start at 25. So, number 4 says define the lower class limit of the subsequent classes, starting with the lower class limit of the first class and just adding on the class width. And you do that repeatedly until you have all your classes defined. Okay, so again, this doesn't really come up in MyMathLab, but if along the way you're doing some statistics out in the real world, you might come across it. All right, so we have this worksheet. Again, that gives us a lot of the examples for this section, so I'm going to make a video of that in a little bit. And as it talks about there, it tells you all the stuff that you're going to look at there. And then we go on to stem and leaf plots with split stems. They talk a little bit about this. Again, stem and leaf plots really haven't been discussed yet because they're going to be introduced really on that data displays worksheet. But the idea is when it looks too bunched up, we can use split stems, and you'll look at that. And honestly, I just would rather not go over that right yet, and you can read that over on your own once we do data displays, the worksheet, and that will make a whole lot more sense. I would like to point out that this is a stem and leaf plot that I gathered from the book, and they really left out some stuff. So when you look this over after we do the worksheet, you might add a title and a legend to that sucker, both of which those things we're going to talk about on the worksheet. Now, dot plot is by far my least favorite of these data displays. Here's a dot plot for the data of the number of cars in 50 sampled households, the one that we had done the histogram earlier. And literally, what you do is you draw out the observations, 0, 1, 2, 3, all the ones that are possible that you got, right? And like you say, literally you put a dot above each number of cars when you have that observation. So I think it's a lot less easy to read than, say, just a histogram. So, but it does give us the shape of the data, which is important, and we're going to see on the next page. So let's go to that now. We are going to take this idea later on in the semester a little bit further, but right now we're going to talk about four main shapes of data, and that is uniform, bell-shaped or symmetric, and skewed right and skewed left. So let's look at them, and we've got these little pictures of histograms of some made-up data. Okay, so number one, uniform distribution. The frequency of each value of the variable is evenly spread out across the values of the variable, and you see that down here in the lower left. And this is perfectly uniform. You'll notice the histogram doesn't even look much like a histogram. It's just one flat level. Now, in real data, you'd probably find a little bit of variation. You know, you'd have a little bit of variation going on there, but they're being really exact. Oh, this is exactly uniform. But really, in real life data, you'd probably see a little variation. But overall, mostly, you'd see that evenly spread, and so you'd call it uniform. Number two, bell-shaped. We are going to talk about again a little bit more later in chapters. And what we're saying is that the highest frequency occurs in the middle. Notice it does down here. And frequencies tail off to the left and right of the middle, which means as I get further from the middle to the right and also further from the middle to the left, I get fewer and fewer observations in those classes. Do you see that? It's called bell shape because if you draw a really pretty Christmas bell over it, sort of looks like it. Okay? Now, skewed right and skewed left are down here. And I've got skewed right over here and skewed left over there. Now, skewed right means the tail to the right of the peak is longer than the tail to the left of the peak. Let's look at, again, this is the lower left-hand picture. I have the peak over here, and then I want to see this tail. This is what they call the tail. And it is, this data rather, has a nice long tail off to the right side. So I'm going to call it skewed right. Skewed left is down here in the lower right, strangely enough. And here is the peak there. And again, there's a tail, but that tail is on the left-hand side. And so we call that skewed left. All right. Just to check out that idea, why don't you do number two? Pause me down, and what shape do you think that is? And then start me back up. I personally see kind of like a hump there, and then it looks for all the world like there's kind of a tail over there on the right side. So I am going to call this skewed right. Okay, so those are the notes for 2.2. I'm going to fairly quickly get out the video for the worksheet, data displays. Go ahead and print that off, do that worksheet, and then anything you have issues with, you can watch the video on, or just watch the video to check yourself. And remember, I'm out here if you need me. If you have any questions, please email me or ask my instructor through my math lab, okay?